A common question is to do with electrolytes, because it really does show your understanding of equilibrium and how it works. Basically, an electrolyte is a solution that contains mobile charge carriers. Now, in reality, in these solutions, it's just any ions that are really free to move and therefore can conduct electricity. It is not electrons. Do not talk about electrons being free to move in an aqueous solution. It is the ions that move. Okay? And so the more ions in solution, the better the electrolyte. So more ions equals a better electrolyte. That's kind of a key point there. So if we look at something like hydrochloric acid, it's a strong acid and it completely dissociates. You use that term in your answer. Okay? And therefore it produces chloride ions and hydronium ions. So if we start with 1 mole per litre of this, we end up with 1 mole per litre of that and 1 mole per litre of the hydronium ions. So therefore we've got a high amount of ions, so that would be a good electrolyte. Ethanoic acid is a weak acid, and so even if we start with 1 mole per litre on this side, it's not going to produce 1 mole per litre. It will produce a tiny amount of hydronium and a tiny amount of ethanoic ion, and that's because it only partially dissociates. Because we have a low amount of ions, this would be a poor electrolyte. Now, just to get you some idea, this is not a concept that is just related to acids and bases. Students in their answers will sometimes talk about how it relates to the amount of hydronium ions or the amount of hydroxide ions. Now that only relates to pH, how many of hydroxide ions or hydronium ions are in solution. It's just ions with electrolytes. So if we had sodium chloride, which isn't an acid or a base, it's going to form a high amount of sodium ions and a high amount of chloride ions. And because you've got a high amount and it completely dissolves and ionizes and forms those ions, this too would be a good electrolyte. Its pH would be neutral, but it would be a good electrolyte. Now we look at another salt, ammonium chloride. Now when we put that into water, it ionizes and forms, if we start with 1 mole of this, it's going to end up with 1 mole of ammonium ions and 1 mole of chloride ions. Now, the ammonium ions will react with water and form a small amount of ammonia and hydronium ions. Now the key here is we're used to thinking in terms of ammonium being a weak acid, and you think, well, it's not going to produce many ions on this other side, or you might be thinking on that, but that's not how you should look at it. There's a high amount of chloride ions, they're not going to react and do anything, and there's actually a high amount of ammonium ions that form. And even if some of these high ammonium ions turn into ammonia, that isn't going to change the concentration much, because for every 1 ammonium ion that does get converted or reacts to form ammonia, you're going to be producing a hydronium ion on the other side. So in this case, we'll still have 1 mole of cations, the ammonium plus hydronium ions that may form, and 1 mole of chloride ions. So this is going to be an excellent electrolyte, okay? And that's because it is a salt, and when it is put into water, it forms the ammonium chloride ions, and hardly any of this is turned into ammonia. And when it does react, it does actually form some hydronium ions as well. Okay, so those should be relatively straightforward. And you've got all sorts of other examples. Like for instance, HF. Is that a good electrolyte? Well, if you put that into water, it's a weak acid, so it's going to form fluoride ions and hydronium ions. So yes, there are ions here, but they're in really low numbers. So it's going to be a poor electrolyte. If you had ammonia, you put it into water, it's going to be a weak base, so it's going to form ammonium and hydroxide ions, but because it's a weak base, it's going to produce very little of these because it only partially dissociates. Most of it's still present in solution as ammonia, which is not a charged particle, it is not an ion. Okay, so make sure you're confident with those.